Now we'll talk about the logistic growth model. This is a really cool model, and we often talk about population growth and how it grows, really without bound. But the reality is there is going to be a carrying capacity. As you see in this graph here, this orange line is the carrying capacity. So a population will reach a carrying capacity that the resources of that environment can support the population. So I just want to kind of illustrate it this way. I guess one way to think about it is, I think a bighorn sheep went to a presentation of a bighorn sheep, and the Nevada Department of Wildlife, and they're talking about the population on a mountaintop, and how if the mountaintop can support life for 50 bighorn sheep, and there are 100, and it's not like 50 die. They all die because of the resource. They don't decide which ones get resources. And so they look for ways to move them to places where maybe one mountaintop can support populations that doesn't have one. And well, that's just a side note. But the way it would work, like let's say your population grew beyond the resource carrying capacity, it would eventually start tapering down and die off until you reached something that hits equilibrium with the carrying capacity. So this carrying capacity acts like an asymptote. So it's a line that it's approaching. So this is a possible scenario as well. But anyway, we're going to do a calculation that this model would have the population kind of start the growth limiting as you approach the carrying capacity. So it's not going to run past it. So logistic growth model is a method of modeling. Let me move this centered better. Population growth in an environment with a carrying capacity. F of x equals c over 1 plus a e to the negative bx. So c over 1 plus a is the initial value. C is the carrying capacity or limiting value. B is a constant determined by the rate of growth. So we could do some calculations. An influenza epidemic spreads throughout a population rapidly at a rate that depends on two factors. The more people who have the flu, the more rapidly it spreads, and also the more uninfected people there are, the more rapidly it spreads. These two factors make the logistic model a good one to study the spread of communicable diseases. And clearly there is a maximum value for the number of people infected, the entire population. For example, at time equals 0, there is one person in the community of 1,000 people who has the flu. So in that community, at most 1,000 people can have the flu. Researchers find that for this particular strain of the flu, the logistics constant is B equals 0.06030. Estimate the number of people in the community who will have the flu after 10 days. And so T is in terms of days. Predict how many people in this community will have the flu after a long period of time has passed. Well, I think we already know that answer because that's going to be our limiting number. So when we look at this, our carrying capacity is going to be that 1,000. So we know that. Let me get back to my blue color. There we go. And so we're going to try to find A. So at time equals 0, there's one person who has it. Okay. And so we know that C over 1 plus A must be 1. Because that's our calculation up here. The formula says that's the initial value, C over 1 plus A. Okay. So that means it's 1,000 over 1 plus A equals 1. So if I multiply both sides by 1 plus A, 1,000 equals 1 plus A. And subtracting the 1, 999 equals A. Okay, so our formula is coming together. We have f of x equals c, which is 1,000, over 1 plus A, which is 999, times E to the negative, and our B was 0.6030 times X. So we're going to look at this after, how many days was it? 10 days. So what is F of 10? It's 1,000 over 1 plus 999 e to the negative 0.6030 times 10. And that's going to be approximately 293.8. So we'll just say 294 people. Okay, and then if we think the long term, we expect the entire population to have it. I guess this doesn't take into consideration any kinds of immunities. So I guess Wolverine doesn't live there, right? Because Wolverine would develop immunities. So long term, it's going to be the carrying capacity, C, which is 1,000. People are going to have it. Okay, that's it. If you were to graph it, I believe it's around 21 days, everyone's got it.